Hello students, I am Anurag Gupta, MBA Finance, a topper of University Department Pune, and I am also a CFA from ICFAI University. After spending a few years in financial sector, I left a lucrative corporate career to pursue my passion for teaching. I have been a top ranker in various exams at school, college, university, and even at all India level. And I have consistently produced top rankers from my institute for the past 8 years. And here I must mention that many of my students who were average performers till their standard 10 exams showed excellent results in their standard 11 and standard 12 exams, and even now they are doing really well in their respective careers. Now, with a view to spread my knowledge to the maximum possible students, I have started teaching in online mode as well. Initially, I will bring videos on maths, accounts, economics for the students of class 11 and 12, where I'll cover the entire syllabus in a very systematic way. I'm sure you'll enjoy the process of learning in my lectures. So welcome to my channel. Hello students, today I'll cover chapter on linear inequalities. It is a chapter of class 11 mathematics. Till class 10th, you must have studied equation. It's quite a familiar term. Equation. Equation means we have some relation between two terms or two mathematical expressions, and in between the sign is of equal to, is equal to sign, right? Is equal to, this is equal to 200. So if there is a is equal to sign, that means it is a equation. And if the sign is other than is equal to, then it becomes an inequality. Other than is equal to any sign. It could be less than, it could be more than, less than equal to, more than equal to. Other than is equal to, if there is a sign, it makes the expression an inequality. Now, what is the significance of this? When we find the solution of equation, we get one value. For instance, here, if it is 40x is equal to 200 and we have to find the value of x, then it will be x is equal to 200 by 40 is equal to 5. We get one value of x. But if we place a less than or more than sign, then there will be several values of x which will satisfy this inequality. Here, if I say 40x is less than 200 or x is less than 200 by 40, that means 5. So x is less than 5. Less than 5 means many possible values x can take. Less than 5 can be infinite values, right? And here is the value is equal to 5. X is equal to 5. So this is the significance of the sign. Here it is equal to, it will give one unique value, and here if any of the other signs are present in between the two numbers or mathematical expressions, we will get many values. This is one aspect. Now, if we have to compare here, if we say linear equation in one variable. Now, linear means what? Power of 1. X to the power 1. Y to the power 1. Linear. Power of 1. If it is quadratic, it is power of 2. We are not concerned with that here. Right now, we are talking about linear. So, one thing is linear. Second, it is equation. That means it's related by an is equal to sign. In one variable, that means there is one unknown, one variable. So, one thing is linear equation in one variable. And if we compare it with inequality, we can have a linear inequality. Linear inequality in one variable. Linear means power of 1. Inequality means sign other than is equal to sign. In one variable, that means one unknown, right? This is one thing. Second, here if we take it as linear equation in two variables. Here the variables are 2 in number, that means x and y. Similarly, if we talk about inequality, so what we can say, linear inequality in two variables. So here x and y, there are two variables. It is an inequality, but the variables are 2 in number. So linear, power of 1, inequality, sign other than equal to sign in two variables x and y. So this I am explaining to show you the difference between an equation and an equality. Equation is something which you all know. So that's why I am giving a comparison so that it becomes easily understandable. And why I am telling you this, because when we are solving, when we are trying to find solution of an inequality, we will follow most of the rules that we follow in solving equations. So now when we know what is an equation and what is an inequality, then the next thing that comes here for solving problems will be rules for solving inequalities, and we will see it in a comparison with equation, how we solve equation, and then we will try to apply the same rule in solving an inequality. Then you will be easily able to solve any inequality. For instance, let us take a very easy example. If it is 2x is equal to 4, this is an equation. Now if we solve it without even knowing it, what we do, immediately we will make it x is equal to 2, but actually what we are doing, we are dividing both the sides by 2. So it is x is equal to 2, or the other way of looking at it is, take this 2 to RHS and you can divide it, you can divide 4 by 2 and you get x is equal to 2. So this is very simple, we don't have to go into deep into it. But when we talk about inequality, again we do the same thing. 2x is less than 4. The answer is, this implies x is less than 2. We have done the same thing, we have divided both the sides by 2, or we have taken this 2 to the RHS and we get this answer, x is less than 2. Here we get a unique value, x is equal to 2. Here we get infinitely possible values of x. This is one way. So the rule number 1 is that if we divide both the sides by same positive number, then it will not change the equation. Similarly, it will not change the inequality. We can do this. Second, transposing. If it is 5x minus 3 is equal to 3x plus 1, simply what we do, we transpose the terms. We take 3x on LHS and we take this 3 to RHS and we change the signs. Actually what we are doing here, we are subtracting 3x from both the sides. If we subtract 3x, so we get 5x minus 3x, and if we subtract 3x on RHS, we get 3x minus 3x is equal to 0. That is what is the procedure. But unknowingly we do it like transposing. We take 3x to this side and change the sign. We take minus 3 to RHS and change the sign and make it plus 3. So this is what we have been doing. There is nothing big about it. But the thing is, the same thing we can apply to inequalities as well. This is what is important. The same rule we can apply to inequality. We can do the transposing just as we do in case of equations. So here the inequality is solved in this way. Again, the rule is same. Whatever we do in equation, we have to do the same thing in inequality. Now the main rule, the next thing is, now what I am going to tell is, that is very important thing, that is the main rule, and that is the main area of difference between solving an equation and solving an inequality. So let us come to the third rule. Now let's see the third rule. Third rule tells that if same negative number, the important thing here is negative number. In these two rules, what we saw was that if the same positive number is divided from both the sides, it doesn't change the equation and it doesn't change the inequality. Here what we saw, if the same numbers are added or subtracted on both the sides, it will not change either the equation or the inequality. But now we are talking about negative number. If we are multiplying or dividing a negative number, then the sign reverses. Let's see how. In an equation, what happens if it is minus 2x is equal to 4? It simply becomes x is equal to minus 2. What have we done? We have simply divided both the sides by minus 2. So if we divide LHS by minus 2, it becomes x, and we divide RHS by minus 2, it becomes minus 2. So we have divided both the sides by minus 2 and the equation remains same. But here, if we divide both the sides by minus 2, not plus 2, it is minus 2. If we divide both the sides by minus 2, then the sign will reverse. From less than, it becomes greater than. Again, I'll tell you the difference. Here, it was 2x. Here, it is 2x less than 4. We divide both the sides by 2, not minus 2. Here, it is plus 2. We are dividing both the sides by plus 2. So, it becomes x less than 2. The sign doesn't change. But here, we have divided both the sides by minus 2. So, the sign changes. So, whenever we divide or multiply both the sides by a negative number, the sign reverses. That's all. When we solve problems, we will be more clear about it. One example I'll give you here, how to apply these rules in solving numericals. Now, see this question, 5x minus 3 is less than 7. The whole question is 5x is less than 7. Solve it when x is an integer, and secondly, if x is a real number. So the solutions will be different in both the cases. So these are the two cases mentioned. So first of all, we will solve it. This method will be same in all the cases. This will come at a later stage. First, we will solve with the rules that we have learned just now. 5x minus 3 is less than 7. So what will we do? We will take this 3 to the RHS. So 5x is less than 7 plus 3. X is less than 10 by 5. So actually it is 5x is less than 10, and then this 5 comes to RHS. So x is less than 10 by 5, just as we solve equation. That's why I am talking again and again about equation, because we are very familiar with solving equations. We have to apply the same rules here. Only in one case, when we have to divide or multiply by a negative number, then we have to reverse the sign. That's all. Remaining every single step is same as we do in case of equations. So the same thing we will do here. Just as we solve equation, we will solve this inequality, and finally it comes x less than 2. Now the difference is here. The solution of an equation would be x is equal to 2, but now here we are not concerned with that. Now we will talk only about inequality. It is x less than 2. Now this is not the final solution set. The solution set will depend on the cases given in the question. Here, there are two cases given. First is if x is an integer. So, x is less than 2. This we know. We have worked this out that x is less than 2. But actually, the solution set will depend on how x is defined. When x is an integer, it will give different solution set. And when x is a real number, then it will give a different solution set. Let us see how. Now, when x is less than 2 and x is an integer, what values can x take? Less than 2, that means 1, 0, minus 1, minus 2, and so on till infinity, minus infinity. So, how do we represent that? In set theory, we will make a curly bracket, and in that we will write dash dash minus 2, minus 1, 0, comma 1, and then we will close the bracket. This shows that this will go on indefinitely, this dash dash. So when x is an integer, the solution set of inequality is this, and if it is a real number, that means all the values, fractional and all the values are included here. So this will show by this notation, small brackets, minus infinity, and 2 is excluded. 2 is not included in the solution set because it is less than 2, not less than equal to 2. It is x less than 2. So because it is less than 2, 2 is excluded from the solution set. So we write it as 2 followed by small bracket, right? So when x is a real number, then solution set of inequality is minus infinity to 2 bracket closed. So this is how we solve these questions, and now we'll solve other questions of exercise 6.1. Let's solve the questions of exercise 6.1. Question number 1. Solve 24x is less than 100 when the first condition is x is a natural number x, and the second condition is x is an integer. Let's first solve the inequality and then we will come to these cases. The inequality is 24x is less than 100. So it's very simple. On the LHS, x will remain and 24 we'll take to the RHS. So it becomes 100 by 24. So x is less than 25 by 6. X is less than 4.17. Now we will apply these cases. If x is a natural number, then what are the possible values of x? X is less than 4.17. So what are the values which are natural numbers which are less than 4.17? Simply 1, 2, 3, 4. These are the natural numbers which are less than 4.17. So when x is a natural number, the solution set of the inequality is 1, 2, 3, 4. In set notation, we are showing it. Now, the second condition is when x is an integer. Now, if it is an integer, if x can take these values, if x is an integer, then it can even take negative values. So, we'll go to the left side of 0. We'll include 0 and the left side of 0, and this is how we show it in set notation. We'll put dot dot dot. That means it goes on indefinitely on the negative side. So dot dot dot, -3, -2, and up to 4 we will show, because it is 4, x is less than 4.17. So 4 will also be included in this solution set. Fine. The next question is solve minus 12x is greater than 30. Again, the two conditions are given. Let us first solve the inequality, then we'll go to the conditions. Minus 12x is greater than 30. Now here it is very important. This is a very important case. Here, see, the sign of inequality has reversed. Why? Because this minus we have taken to the right hand side, or we can say that we have divided both the sides by -1. So what happens, or we can say we have divided simply by -12. So because both the sides we have divided by minus a negative quantity, that is why the sign of inequality has reversed. From greater than, it has become less than. This is very important. In fact, the most important concept in this chapter can be said to be this, that if the same number is divided or multiplied, the same negative number is multiplied or divided on both the sides, then the sign of inequality changes or reverses. So here x is less than -30 by 12, x is less than -2.5. So now we'll apply these conditions. When x is natural number, so solution is phi, or an empty set, because less than -2.5, there is no natural number. And when x is an integer, obviously there are values possible which can be -3, -4, -5, and so on. This is how we show it. Next question, 5x minus 3 is less than 7. So 5x is less than 7 plus 3, x less than 10 upon 5. So x is less than 2. Now if x is an integer, the values can be less than 2. That means 1, 0. Not 2 is not included, 2 is excluded. So 1, 0, -1, -2, and so on. Now here, when x is a real number, this is an introduction of real number here. When x is a real number, then solution set, now this is shown as this small brackets we show, and from -infinity to 2, where 2 is excluded, because this small bracket shows that 2 is excluded. Right? Now the next question, 4. Solve 3x plus 8 greater than 2 when x is an integer, x is a real number. Similar way, we will solve the inequality and we will get the value as x greater than -2, and then if it is an integer, the values are from -1, 0, 1, 2, 3, and positive side it will go on indefinitely because it is greater than -2. -2 is not included, so we will start from -1, then 0, 1, 2, 3, and so on. And when it is a real number, when x can take real values, then what are the possible values of x? It is shown by this -2 excluded to positive infinity and small brackets. This is the notation for real numbers. And now the next question type is, now here we will solve the questions for real x. Here it is not mentioned for integers, for natural numbers. It's assumed, or it is given to be solved for real x. That means whatever we are solving, it is for a real x. X can take real values. So here again we will solve the inequality by applying the rules. So 4x minus 5x is less than 7 minus 3. So minus x is less than 4. Again here we have divided both the sides by minus 1. Or we can say we have multiplied both the sides by minus 1. Whatever way we can take it as. But the main thing is, if we have divided both the sides or multiplied both the sides by a negative number, then the sign reverses. Sign of inequality reverses. So from less than it becomes greater than. So the solution is minus 4. X is greater than minus 4. Greater than, not greater than, equal to. So minus 4 is excluded. So minus 4 to infinity. Then it is 3x minus 7 greater than 5x minus 1. And so this, when we will solve, we'll get x is less than minus 3. And that means the solution is minus infinity to minus 3. That means 3 is excluded. Okay. And these are usual questions. I'll go through it a little faster. So here, first of all, the brackets are given. We will open the brackets. It becomes 3x minus 3 less than equal to 2x minus 3. Here the sign is of less than equal to. So the final answer is in terms of less than equal to. X is less than equal to minus 3. This basically, these steps are usual steps. As we solve in case of equations, we have to solve in a very similar way. Only I told you the caution that we have to take is that whenever negative number is multiplied or divided on both the sides, in that case we have to reverse the sign of inequality. Other than that, we apply the same rules as we do in case of solving equations. So these steps are very usual steps, that x terms we take on the left hand side, the other terms without x we take on the right hand side, and we solve. So x is less than equal to minus 3. Less than equal to, when we say, that means minus 3 is included. This is a new thing here. So that we show by a square bracket. So minus infinity to minus 3, where minus 3 is included. So we use this square bracket. This is a new concept in this question. And then the question 8 is again of a similar type. We'll move on to question number 9. Here these values are given. So we'll simplify this. So we get 6x plus 3x plus 2x is less than, we'll take this LCM to right hand side and it becomes 6. 9x is less than 6, so x is less than 6 by 9 or 2 by 3. The solution is minus infinity to 2 by 3, and 2 by 3 is excluded. So the next question is question number 12. 1 by 2 into 3x upon 5 plus 4 greater than or equal to 1 by 3 x minus 6. We'll first of all simplify these terms. We'll open the bracket and then we'll solve in the usual way. This is how we'll go about it. So this bracket, when we'll open, we'll take this 5 to the right hand side, and this becomes 9x minus 10x greater than or equal to minus 60 minus 60, because this 60 will take to RHS and 10x will take to LHS. But here again, minus x is greater than or equal to minus 120. Now if we have to remove these negatives, we'll divide both the sides by minus 1, or obviously we cancel out, we say we cancel out these negatives on both the sides. So it means the same. The thing is, if we divide or multiply by minus 1 on both the sides, then we'll have to change the inequality sign. This we have to take a lot of care. This can be a big careless mistake if you do not take special care here. So this is the only area of caution where we have to be very careful. So the sign will be reversed, and finally the solution will be minus infinity to 120, 120 included. And then we'll skip the similar type of questions and we'll move on to the question number 15. Here only the form looks a little complex, but these are all very simple and usual problems. If we think in terms of an equation, these are very simple terms. We'll just have to simplify, open the bracket and solve just as we solve the equations. Only thing is the sign will keep as the inequality sign. And finally, if
this happens, minus x is less than minus 4, and we have to make both of these positive. So we will change the inequality sign. It becomes x greater than 4, and the solution is 4 to positive infinity and 4 excluded. So this is how, these are all very easy, very simple questions. We just have to take care of the rules of solving inequalities. And in this lecture, we have seen the algebraic solution of inequalities. And in the next lecture, the part 2 of when I'll cover the remaining part of exercise 6.2, in that I'll cover the graphical or the number line solution of linear inequality in one variable, and also we'll solve some word problems. So that's all for today.